So we're looking at some of the gas laws. We've got various bits of kit set up. We're going to show you some of the good things and some of the bad things. So what we've got here, this is our pressure and temperature investigation. So what we're going to do is got a Bunsen burner at the bottom. We're going to light that. Obviously that's going to heat the water up. The water's then going to increase the temperature of the air inside the little flask, and then the flask is going to measure that change in pressure on the gauge at the top. Now we've got quite a high resolution there. We should get some decent sets of reading. Things to watch for is the rate of heating. We can't have that on a roaring blue flame, because then the temperature of the water gets higher than the temperature of the air inside. So we need to heat it quite gently. Now, in a lot of the textbooks, in terms of the heating that they show, there's some really bizarre setups. One of the worst ones we've seen is that, you should see this at the back, we've got a little electric hot plate with a huge vat of water on the top of it, and we're supposed to put the flask into that. Now, with the best will in the world, that's never going to heat that volume of water up. It can be running all afternoon. You're going to get such a small variation in temperature. It's going to be crazy as well. So we don't want to use that. We do say want to use the Bunsen burner, but we don't want to overheat it, because then the rate of heating gets too great. We need a gentle heating effect, and we're looking for, say, the variation in the pressure here on the gauge, and we're going to record the temperature just there. Okay. Other gas laws. We've now got the variation here with volume of the temperature as well. So tomorrow we're going to put this flask in the water here, and again we're going to heat this up. The air is going to increase inside, the temperature is going to go up, and the volume is going to increase, and then the cylinder is going to fill with the expanded air and push the piston back. Now we need to check, because a lot of these cylinders and the pistons, they aren't a very good seal, and you really shouldn't be able to do that. Atmospheric pressure should stop the piston moving back, stop it moving forward. As you can see in this case, it's really quite leaky, and that would give us a very bad set of results, because we're losing air from the system. Another thing to note here is we've got the thermometer actually inside the bowl, so we're recording the air temperature directly, which is in contrast to this setup here, where we're recording the temperature of the water, which is why we need to have that gentle heating, to make sure that we don't get a lag between the temperature of the water and the temperature of the air. I think that's just about it. So we're going to do a set of results for this. We'll put the results up on the board, and hopefully we can plot a graph, and we can extrapolate and hopefully find some values for absolute zero.